So let's do a real quick overview of texture coordinates. Now this might not seem like the most interesting subject, but we're going to build on some of this stuff in the next parts. So let's just overview it very quickly. And to do so, I'm just going to create two Suzannes to be able to talk about stuff quickly here. We'll put them up here so we can see what's going on. And let's switch over to our material preview. There we go. Now, for the first Suzanne, I want to talk a little bit about principled texture setup and how to make things a little bit quicker. So let's say Suzanne over here doesn't have UVs. She does, but actually let's delete them. There we go. She doesn't have any UVs, but we want to texture very quickly, and we don't want to deal with UVs and do stuff the long way around. So one of the things I could do is with the Node Wrangler add-on enabled, we've got the added principled setup over here. And if I select the principled BSDF and just hit Control-Shift-T and go into the textures, just hit A to select all the textures, click principled texture setup, and now it's going to bring in those textures. Now, as you can see, we just get a brown color. This is supposed to be a brown mud texture and mud map, but nothing's really happening. And that's because obviously I deleted the UV map, so it doesn't really know how to map these textures. Again, though, I don't want to use UVs. I kind of want to get away from them. So setting this to object, we can see the map is now projected from the top, and it kind of looks okay from here, but it doesn't look okay from here. Now, a very quick way to get around this is to actually set the, in the image texture, set the projection here to box rather than flat. What that's going to do is it's actually going to project this from 6 sides and even can blend this together a little bit. So now we've got our map being projected onto Suzanne, and you can see a little bit of a seam here, which if you use the blend, you can take away. So just by blending this a little bit, you might want to set these to about the same on each, or exactly the same rather on each one of these textures. But now we've got this map set up. We didn't really have to do anything for it, and it works nicely, and we don't have to worry about the other stuff. So this is a very quick way to set up, I guess, image textures without having UVs or without having to unwrap. Now, let's go to the other Suzanne here and create another new material and just very quickly talk about the 3 main, I guess, texture projection modes. So with the, let's grab, what are we going to grab? Grab a noise texture. And just keep it simple for now. And Control-T, so this is an add texture setup in the Node Wrangler here, and I'm going to close this because we don't really need that. And just by hitting Shift and Control, holding it down and clicking, I can see the final result here as well. So now we've got a texture setup, and by default, if nothing is plugged into the noise texture, it's actually going to use these generated coordinates. So if we plug these in, you'll see nothing really changes. And I just want to talk about generated versus UV versus object real quick. Now, most of the procedural textures that you're going to use in Blender are actually 3-dimensional or 4-dimensional in some cases, because they can be animated through time. There's like an evolution in it. But there's 1 or 2 exceptions, and one main exception is the brick texture, and I'll talk about that in a little bit. I'll just put it in here so you can see the difference. Now, the reason I want to talk about these textures real quick is, or these texture coordinates rather, is it's good to know how they're actually working. So I'm just going to increase a little bit of contrast here, and we'll talk about that color ramp in the next video. And what I want to show you is that these generated coordinates, if we, example, really squish Suzanne down, you're going to see these generated coordinates. What they're actually doing is they're grabbing the bounding box of Suzanne, and we can even visualize that. We go into the viewport display and showing bounds. And it's gonna, if I look from the top, it's gonna start projecting from here and project the texture out. And it's gonna sort of squish it depending on the size of the object. So if I go back in and scale her back up, you'll see now it looks a little bit more normal, and that's because the bounding box is just a little bit more square. What's important to note as well is it actually uses, I believe, the bottom left corner so as the starting point for the texture. So if we scale this down, you can see this is actually being scaled. And if we grab all 3 of these, you can see it's scaling down from the bottom left corner. So while generated is the default, I would actually argue it's not the best one to use because you're going to get weird squish textures. And especially when you're just messing with this stuff, you don't, you want predictable results. So in that case, you could either use UVs. Now, Suzanne has default UVs as we create, or you could create your own. The problem with UVs is what you see immediately is that you'll get seams. And that's generally while I'll switch over to object, as I did with the other texture that I created here. We switched this over to object to project these, and then set this to box to actually project them from all sides. Now, going back to the other one, the main difference between generated and object is if I squish Suzanne back down again, you'll see the texture will actually stay in its normal ratio and the projection will just be exactly the same. Doesn't matter on how large or small she is, it just works. And that's kind of the reason why I like using object a little bit better. As well as if we mess with the scale, now you'll see it actually scales out from the origin point. So if I were just to switch over to black box here and then move my origin up, you'll see I can actually control this with the origin being moved around. Or if we want to get really fancy with it, we could have an empty, and we could have that empty control the texture coordinates as well. So now when I move this around, you can control it with that empty. Scaling, rotation, all of that applies as well. So it's good to know that you can control it with multiple different things. And generally, I'll be mostly switching between these two, and it's just good to understand the differences between them. Now with this set to object, and I'm just gonna delete the empty here for a second. If we plug this into the brick texture and grab it, this is what I mean by some of the procedural textures in Blender are 2D and some of them are 3D. And the brick texture is a really great example of a 2D procedural texture. Unfortunately, it doesn't understand that it's being projected from all sides. Well, it kind of does, but it only really works in one direction. So you could turn it around if you wanted to, but again, you'll always be left with sort of two dimensions not looking completely correct. So here at the top and on the side, it doesn't look correct, but from the front, it does look right. So it's usable in certain situations. If you're dealing with a flat object, just like a wall or something, it might be useful. But just to show you the difference, if we grab a checker texture here instead and plug that in, you can see this one is actually 3D. It does follow the shape of the curve a little bit, and it is projected from all sides. So just make sure that when you're using some of these, you understand the differences. Most of them, like the noise, let's see. So the brick is 2D, checker is 3D. Environment is a special one just for your environment. Gradient is 3D. IES is for your lights. Image texture is going to be 2D unless you set it to box, and then you can you can project it the way we did in the first shader. And then magic texture is 3D, musgrave is 3D, noise is 3D, point density has to do with particles and volumes. Sky texture again is for your environment. Noise 3D, and same with the wave and the white noise. They're all 3D textures. So this is a very quick overview of some of the procedural textures that are in here and how to understand mapping coordinates. One last little thing is in Blender, when you make the scale value larger, it's actually going to make the texture itself smaller. And when you scale down, it's actually going to make the texture larger. Don't ask, it's just the way it is. I'm so used to it, but I thought I would mention it in case you got confused by how that behaved. And that's it. If you want a little bit easier to navigate behavior, you can always just grab an empty and scale it up and down, and then you just have a separate object to control it. But yeah, that's a very quick overview of texture coordinates, and let's move on to the next video. So in this example, let's quickly talk about range mapping and color ramping and how they're actually quite useful. So once again, we're going to drag poor Suzanne into this and shade smooth, and we'll just set up a very simple shading setup. Now, the reason I want to talk about this is because I use it all the time in my work, just because it's incredibly easy. So let's start with something very basic. So grab a noise texture, and I already did this kind of in the last video. So with this noise texture thrown in here, let's go to our material preview, and now we can actually see it. So first of all, what's the difference between the two? Let's start with the map range. Now the map range is kind of cool because basically anything you put into it, you can tell Blender, okay, I want you to output basically whatever's from between these two ranges, so 0 to 1, and change that to the different output down here. So for example, if we set this from, let's say 0 to 0.25, now all of the ranges are going to be clipped between these. Now I know from experience that the noise texture doesn't really hit black and white completely. So what we might need to do is just bring up the minimum, which is like 0.2. And now you can see it's going to bring down, if we bring down the maximum as well, I'm going to start clipping a little bit, but we know all of these values in between here, it can be between 0 and 0.25. Now this is incredibly useful for something like a roughness map or a specular map or something like that, where you can really just dial in exactly the amount of roughness you want from either a procedural texture or an image texture. Now compare this to the color ramp, which has sort of a similar function, but not really. So I'm going to set this to 0.25 and see if we can actually get about the same result. Now you can already see this is looking slightly different, and that's because there's some color stuff going on in the background as well. But essentially you can create a similar sort of effect. Now, the reason I'm showing it both ways is because the color ramp allows for some more artistic effects, which we'll look at in just a second, and each of them have their own merits. If I go to the range mapping here, I know this value is going to be exactly 0.25. If I go to the color ramp, while I've set the value to 0.25, there's still some color stuff going on in the background, which means depending on my view transform and other things, it's actually not going to be exactly 0.25. So generally for data maps like specular and roughness, I'll stick with the map range unless I want to do something artistic, and then I might move on to the color ramp. Again, it switches. It's not a hard and fast rule, but sometimes you just need a bit more precise control, and in that case I would definitely recommend using the map range node. Now some other cool stuff it can do is actually stepped and step linear, so you can actually add in steps here. You can get sort of a posterized effect, so there's going to be two steps between the start and the end, I guess, or I don't know, the steps are set to 2, but we've got 3 values, so depending on how you want to interpret it, I guess this does or doesn't do exactly what it says down here. But it's just good to know that you can, like I said, add more steps in here, get more of a posterization effect, and you can put all of this into all these maps as well and get some really cool and funky results. Then you've got the smooth step, which is sort of like a stepped effect. And let's see if we set this to 1, if we can't see it a little bit better. And you can kind of see it around the edges, but it's not super visible. Again, smoother step will also create a stepped effect, but a little bit smoother. Generally, the ones that are the most useful are linear and stepped linear. You can see there's a quick explanation for each one. So there's a bit of interpolation around the edges of the values, and yeah, again, it depends on what you want to do with it. Now, one more cool thing you can do as well, if we look at linear, one last thing I want to explain. Let me close this back up again real quick. So we can clamp these values. So let's say there's values here that go way up above whatever we're trying to clamp down to the output values down here. If we turn on clamp, which is turned on by default, it will actually clamp these minimum and maximum values. If there's value ranges that fall outside of it, you can actually get values that are lower than 0 or higher than 1 if you turn off the clamp. So for some options, it might be interesting to turn it off, but it's good to know that it's in there if you need perfect values coming out and you want them to clip to the values down here. Now for the next example, I'm just going to open up a texture really quick that I grabbed here, and this is another thing I wanted to show you. Let's say we put the color ramp in here, and let's actually, what we can do, I'm going to delete this color ramp, I'm going to put in a new one, and we're going to use this map range that we've created, and we're going to use that in our color ramp. So let me make sure we've got some values going from black to white. And now this is exactly the same. It's not going to change between the two. But what I wanted to show you is some of the options that we have here. For example, one of the most fun ones is the eyedropper options. And the moment we click on this, we can click and drag over this image. And we won't really see anything happening until we let go. And now it's grabbed a whole bunch of colors from that image in that point. So let's see if we can actually see this. There we go. I just needed to update it. And now we've got all these stops that we've created just by dragging the eyedropper along the image. Now, a few other things which are really, really nice. You can distribute the stops evenly. So now you've got them all evened out, and really, or just reset the color ramp or flip it really quickly. But it's really good to know that there's a whole bunch of options in here that you can use. And you can, if you have a whole bunch of color swatches like this, you can easily go between them just by using the number down here, and you can change the position as well. And again, if we were to change the positions of some of these, for example, we can redistribute them evenly, and this is going to even them out really nicely. So for all kinds of crazy effects, the color ramp is way more useful than the map range. So again, generally, if you want tight controls, map range is going to be your best friend. If you want to do something a bit more crazy, the color ramp is going to be your best friend. If we just reset this real quick, again, we can color it any way we want. So this is going to color from black to white, and we could change it, like I said, any way we want and create sort of any effect that we want. Or we just duplicate this once more and actually set this to reset. Once again, this time I'm going to just hit the E key. So if I hit E, that eyedropper is going to show up, and this time it'll actually show us. You can see that I'm generating them, and there's a whole bunch. And if we put them in here, same thing will happen. Again, we can distribute them evenly again. And distribute stops from left, I believe, is, let's say we've grabbed them over here and we've got the black one in here. You distribute stops from left. It's just going to grab all of these and distribute them from start to finish. But rather than distributing them evenly and having one at the end, it's going to leave this last one open. So that way we have the three colors. If we set this to constant, for example, now we'll have a nice evenly colored color ramp. And that's one last thing to talk about as well. We've got easing options in here that we can choose. Generally, linear as the default is the one that I use the most. Constant is very useful as well, just for hard edges. So you can get sort of a stepping effect like we had in the map range, but you can do it in the color ramp as well. And the final one that might be useful is the B-spline. And this is actually going to create sort of Bezier curves in between the colors. And you can see if you want a color to propagate, you'll actually have to have two stops in there that are about the same to really have it propagate properly. And it's just, you can see by the, I guess, the color distribution up here, it's a lot softer and it gives you a lot more control to fade some of these colors in and out. So yeah, there's a lot here to unpack, but again, this is just really a really quick overview of why you would use these two, and they're just so useful for so many things. And we'll get into them a little bit later as well, into some other ideas and examples. So with that said, let's actually move on to the next video. So let's talk about bringing some randomness into our shading. And for this first one, actually what we're going to do is we're going to look at how to create extra randomness on an object level. So to do so, I'm just going to create a whole bunch of cubes. I'm going to duplicate these. And that way we just have something to work with. Now, with all of these selected, and I'm actually going to make this a little bit smaller because it doesn't really matter for now. Let's put a material on this last one, and then just hit Control L and link it to all the other ones that are selected. So now this material is used 72 times, as you can see over there. So this is the little indicator. And basically what I want to talk about is, let's say we want to have all these cubes be a different color. So to do that, we're going to talk about the object info node. And specifically in the object info node, I'm going to set this material preview on. There we go. I want to talk about the random node. So if we just move these around, you can see we can preview all of them, but the random one is really one that's the most interesting to talk about. And what this is going to do is it's going to, basically every material that this object is on, if you use this random output, it's going to create a value between 0 and 1 randomly on each of these objects. Now what's good to know is if we, for example, select a whole bunch of these, let's select this last row, duplicate it over, you'll see as they get added in, more of them will create get randomly assigned colors. And the way we could use this for shading, for example, is in conjunction with a color ramp. So if I grab this color ramp and put it in between, nothing's really going to change. But let's say I want some of them to be red, some of them to be green, and some of them to be blue. I could set this to constant. And now I have basically a mask with a bunch of them that I could select. And if I control click here, I can have another mask. Let's actually set up the colors that we wanted to. So red for the first one, green for the second one, and blue for the final one. And now we can control the ratios just by moving this around. Now the cool thing is this basically allows you to create really random shading without having to do much work. And it's important to note that this works on object level. There is another one, but unfortunately it doesn't work in Eevee, but it does work in cycles. But I wanted to mention it anyway. It got added fairly recently to Blender. It's called the random per island. Basically what this is going to do is each unconnected piece of mesh. So let's say if we have Suzanne, for example. Where is she? There we go. Move her over. We add in a new shader here. And let's grab the geometry node and put in random per island. You'll see, unfortunately, this doesn't work in Eevee or in the material preview. Now, were we to switch to cycles real quick, it's just to show you as it jumps over, you can see because these three parts aren't connected to each other in the mesh. Again, if I grab this part, you can see it's separate from the others. This does work in cycles, but unfortunately it doesn't work in Eevee. Again, I just wanted to show you just in case. You could use this to bake, for example. You could bake this texture down and then use it in Eevee if you wanted to. But again, if we switch, unfortunately, it doesn't work. But it's good to know that it's in there, that you can do it on multiple levels. So I'm just going to delete Suzanne here. Now, not only can we use this to color this, but again, if we wanted different roughnesses, for example, so let's go back to our material preview and let's maybe put this in base color. Yeah, again, you could use it for all kinds of different stuff. So we could have multiple color ramps coming off this and doing different things. Or in our case, we could use a map range as well. And this way we know that we grab these values. We know they're going to go from 0 to 1, so we don't have to change this. But let's say we want to go from 0.1 roughness to 0.5 roughness on each one of these. We plug that in. You'll see we'll have different roughnesses. You can kind of see it. You see how we have different roughnesses on each one of these objects, which is really nice. And yeah, we can adjust it interactively. We can even set this the other way around. So where we want the lower values to be rougher and the higher values to be more shiny. And you can see that happen because the red ones are sort of in the lower value range, the blue ones are in the higher value range, and now those ones are actually quite shiny, and the red ones are actually quite rough, and the green ones stay in between. So yeah, there you go. That's just a very quick overview of how to shade randomness. And I use this stuff all the time, and we'll look at a more advanced example in a few videos. But it's really good to know that it's in here and you can do some really interesting stuff with it. So yeah, it's time to move on to the next section. Another area where we could use random shading is hairs, for example. So I'm going to set up something quite similar to what we created before when we were talking about the hair caching, just so we have something to work with. And again, all I'm going to do is just add in a hair system. I'm going to set the viewport display up a bunch of sections and same here, segments rather. And all we're going to do is add in a turbulence force field, just so we have something a little bit more funky to look at and to work with. So there we go. This looks kind of crazy, but that's fine because we're going to talk about shading more than anything else. So let me set up the material preview here and select our object. So by default, if we throw on a shader here, it's just going to use the same shader that's on the object for the hair. And I'm not going to focus on creating realistic hair. I just want to talk about how you can add randomness and some of the other options that we have in the hair info node. This is really great because, first of all, the is strand option basically tells Eevee if this is a hair strand or not. And if it isn't, it's just going to return a black color. And if it is, it's going to return a white color. So you could use one shader on your object and your hair and have a mask to only affect the hair, for example, or run material rather with multiple shaders on it. And kind of control it that way. Also, you could set it up where in the particle system itself, let's see, I believe under render, you can choose a second material in the material slot if you really wanted to, but that's neither here nor there. This is more just to talk about the hair info node in general. Then the second option we have here is the hair intercept. And to show this, I'm actually going to throw a color ramp in between here. And as you can see, what this does is it gives you a black to white mask from the start to the hair to the finish of the hair. And this, especially if we look at timing over here, if we add some randomness, this will actually respect the overall length of the hair, which is great because it means you can really dial in a mask the way you want it. And if I just set this back out to not have any randomness, you can see every time at the start of the hair, it starts sort of black and dark. And let me render these hairs a little bit thicker so we can see what we're doing. There we go. And maybe go back into the particle system to thicken them up a little bit more. So hair shape, let's set this to maybe 10. And now we get a crazy mess, but at least what I'm talking about is a bit more visible. So there you go. You get a nice little mask that you can use. Same idea with the thickness, only the thing with the thickness is you really have to set them very, very thick to see a result. So you might want to use a map range on this. So while the thickness is still active, if I set this back to 1 or maybe say 5, just to show you, the thickness, if your thickness would be 100, then the value would be white, basically. So what you'd have to go in and, again, grab a map range and maybe set this to 0.05, and then you'll get from black to white, because it ends in a, where's the end thickness here? So the tip thickness is 0. So again, this is another way of controlling this, depending on if you have hairs that are thicker or less thick in different places. So, yeah, it's useful, but the one thing I really, really want to talk about is actually the random. We're going to skip the tangent normal for now because it just, you know, shows you the normals of the hair. And unless you want to do something really specific, it doesn't really have any effect on what you're doing. And the random is kind of the same as the random in the object info node, where each hair gets a random value. So again, what we could do is we could throw in a color ramp, for example, and we could have most of the hairs be orange if we wanted to, and then a few of them maybe white or a little bit darker, so they become gray hairs or something like that. That's just another way of shading stuff. And again, we're just looking at this without a material. So if I plug in the material, this doesn't have to be a hair material specifically. It can be a regular material as well. You can see you could do some fun stuff with it. Or if you really wanted to push it further, say we have 2 colors in here just to make it a little bit more interesting. And then maybe I want a couple of these hairs again just to be emissive. You could throw in a second color ramp, type that in there, set this to constant, and when I preview this, again, this is just a mask for a few of the hairs, and we could throw in a mix shader. We wanted to type this into the mix shader, type this first one in here, and then add a emission shader in here. And now we've got a bunch of emissive hairs in between the other hairs. And you can see how quickly you can generate really fun and interesting effects with this. We could even change the color of this to have a bit more dynamic. And obviously this isn't the best color palette in the world, but again, it's more about just having fun and finding something that works for you. So yeah, this is a very quick overview of the hair info node with the random node in particular. And with that said, I think it's time to wrap this one up and move on to the next session. So when you're doing procedural modeling, there's actually also a way to control your, I guess, materials a little bit more procedurally as well. And I'm just going to show you with a couple of simple examples. I'm going to start with a cube here. Now what I want to do is on this cube, I'm just going to throw on a solidify modifier, give it a bit of thickness. And we can't really see the inside, so what I'm going to do is set a wireframe on top of it. And now we've got a cube, just 2 cubes inside of each other that we can use. And one of the reasons I wanted to show you this is, let's say, and actually let's not do this with the material set up here, but let's just do it over here and grab 2 materials, call the first one red, and change the color to red. So let's set up the material preview and just call this material blue. And I think you can already guess what kind of color I'm going to change this to. And the reason I want to set it up this way, let me set up a green one as well, just to push this even further. There we go. So one of the things you can do is actually offset materials whenever you create new geometry with modifiers. So this is really great because you can see now we've offset the inside that we've created. So this is created by the solidify. If we just turn off the wireframe, this inside box is created by the solidify, and we've offset the material once. Now what we could do is with the wireframe do the exact same thing, and now you're going to see the red is going to be offset to blue because it's offset once, and the blue is going to be offset to green because it's offset once. If we were to flip these around, then you'll see some of this might or might not change, and it really all depends on how this has been set up. So they do take into account the, I guess, when we look at the materials, the order of the materials, but because we added in the red first, if I bring in the green, the reason this turns blue is because by default, if you add a new material, it's going to assign all the polygons to that material. But if we move these around, it's going to keep that original assignment. So what's happening now is if I turn off the wireframe, the original red in here is it's actually still red. And I should have done this in a better way. So let me delete the top polygon here. There we go. So don't want to fill the rim, and I want to turn off the wireframe. So what happened is the original red is still assigned, and this is going to turn to blue. But once we turn on the wireframe, unfortunately, it doesn't have any other material outside of that. So it doesn't go back. It doesn't know what to do. It can't go further than blue, and it doesn't loop back around to green. So it just stays the same. If we bring this green back down, then it should work. If we bring this green up and we select all of the polygons and assign it to green, we're actually going to get red. Let's see, red for the inside because we've now assigned this to the first green material, and then green for the original. And again, when we turn on the wireframe, we get the same effect as before. But this applies to all of your setups. So let's say this one, the top one, is set to red. And actually, let's bring back our original setup. So grab everything, assign this to be red. But the top one, I want to assign it to be green. And now, got to assign everything. There we go. And just the top one, I want to be green. There we go. And now we can even have different colors within our wireframe. If we turn off the material index offset, you'll see, again, this changes because it has them offset by 1. And this just goes to show the amount of control this can give you. So really all I want to do, if I just reset this completely, we've got red, green, blue, we've got red here, and then we've got green for the inner one. And again, we've got blue for the wireframe, and it's going to offset all of them. Or if I turn off the wireframe, what we could do is we could grab a bevel and do the same thing where we offset the material. And now if we offset the material to like a ludicrous amount, which is way more than everything that's in here, it's going to grab number 79, but because the index ends at the third one here, what's going to happen is it's going to grab the final one. So you could set this to something like 99, for example, and make sure that it always has the final material, I guess. And it's just another way to control it, which means all of your bevels are always going to have a certain material. And again, you can go absolutely wild with this. There's so many modifiers that have this in there, but these three just give you a really good example of how to control it. And generally, yeah, I'll just have a whole bunch of materials in here, and then I can swap them around and play around with them as I'm modeling stuff procedurally and get all kinds of really cool results from it. So yeah, I hope this wasn't too confusing, because I know with the 1 and the -1 and all that stuff, it gets a little bit confusing. It's just good to know you can offset materials. And again, if we were to offset this one, this is going to be blue because it's offset by 2 materials. So the outside is red, and then it skips green and goes to blue because of the double offset. We set this back to 1, it's going to go red, green, and then we could set this to, 1, sorry, not 0, but 1, for example. You can see the red will be offset to green, and the green will stay the same because it's using material in material slot 1. And now it's using material in material slot 0. So these start from 0 and go up. And if I set this to 2, now it's just going to use material in slot 2. And some of them use offset, some of them use actual material slot. It can be a little confusing sometimes, but it's good to know that it's in there and that you can control it any way you want. So yeah, very quick overview, and I hope that was useful. And let's move on to the next session. Now we've talked about texture coordinates and how we can, how we use them and things. And I want to talk about something a little bit more advanced when it comes to texture coordinates. I want to be able to manipulate them and actually generate new sort of ideas with multiple textures. And you'll see what I mean in just a minute. But this is sort of a slightly more advanced concept. But once you get the hang of this, you can do some really interesting stuff. So what I'm going to do is I'm going to create a wave texture. And I'm just going to make sure that this is set to object texture coordinates, so it's being mapped. And I'm going to bring the scale down to maybe, I don't know, 1, something like that. There we go. And now we've just got these straight lines. And I'm actually going to change this on the z-axis just to kind of talk about this a little bit. So now we've just got these straight sort of gradients running along. And really what I want to do is talk a little bit about sort of vectors and how they work. So right now, what we have is we have this mapping node, and we can control these vectors, as in we can mess with the location. So x, y, and z won't do, or x and y won't do much because we're mapping this only on the z-axis. So we can move these around as much as we want, but they're only really going in one direction. We can rotate them around on different axes if we wanted to. Again, rotating it around on the z-axis isn't going to work because of the way this texture is set up. And same with scaling on the x and y won't work, but it will on the z-axis. Now, what happens when we want to mess with these a little bit? Well, we need to understand how these vectors actually work to begin with. And to do that, I'm going to go to Converter. I'm going to go and use a separate x, y, z. And really what this does, it has a vector input, and I'm going to disconnect this real quick. And it's just going to be able to separate the x, the y, and the z axis, similar to how we have different controls here on the mapping node. But for example, just to try and explain how this works is this mapping, because it's object mapping, it starts in the middle and goes from 0 to, I guess, infinity, or depending on the size of your object. Here, because Suzanne is about 1 unit wide over on this side, this is going to be about 1.2, 1.25, maybe something like that. And the other side of this mapping is actually also counting, but it's going to go from 0, so from 0 to 1.25 this way, and this is going to go from 0 to 1.25 minus 1.25 that direction. And we can visualize this by using a map range. So if we set the maximum to -1, now you're going to see this flips over, because these values still exist, they just exist in negative space. So this basically means that all these different vectors, if we do the same thing on the y-axis, we can see exactly the same thing from 0 to about 1 on this end, and from 0 to about -1 on this end. And we can do the same thing with the z-axis. So from 0, because this isn't, this is the origin point of the object, to, let's say, about 1, I would say, again, up to the top, and from 0 to about -1 to the bottom. But the cool thing is we can actually manipulate these now that we've got them separated out. And what I want to do is I want to use one texture to drive another. So what I'm going to do first is set this up so that we can recombine these back together. And if I set the X, Y, and Z back together and plug this back into the wave texture, you'll see if I turn these on and off, they're actually exactly the same because we're not doing anything to them. But what we could do in the Z-axis is we could add a texture to this and just kind of mess with it a little bit. So let's grab just a noise texture. Where are we? There we go. And let's have a look at the factor of the noise. Let's plug this into the object coordinates as well. Scale this up a little bit. And you can see how this just has a little bit of randomness in there. Now, if we throw in a math node in the Z-axis, for example, and I'm going to preview the wave texture in the end here. Nothing's really adding, nothing's really happening except for the fact if we add this in, because we know these values are just linear values going from 0 to 1, adding anything in here, if we add in 1 here, now it's going to go from 0 to 1 to 2, and we can even visualize this if we wanted to. Now you can see it goes from 0 to 1, and there's some bloom happening here, so it's going to 2 up here. So just by adding a value, we can actually manipulate these coordinates, and you'll see that's exactly what's going on, is this moves up and down. Now, what happens if we actually add a texture into here? Now these coordinates will get distorted. So now, depending on the scale of our noise texture, we're actually distorting the z-axis coordinates of our wave texture. So you can see there's no distortion in here. If we just turn this off, it's still the same texture, but now we're using the noise texture to distort this. And we can use any texture in this fashion, and we could use it in any different way. Now, an even quicker way to set this up, and usually the way that I use it, is I'm just going to duplicate this wave texture and this noise texture, and let's plug these in. I'm just going to bypass the mapping node because we're not actually using it. So there we go. I'm going to add in a little extra node here just so we can control this. And the way I usually set this up, without separating out all of these and having all the individual axes, what I'm going to do is I'm just going to grab a math node. I'm going to duplicate that math node, and then I'm going to grab a vector math node. And basically what I want to do is I want to use this noise texture sort of as a secondary vector to add in to this vector for the wave texture. So I'm doing the same thing as I'm doing up here, but I'm just doing it on all 3 axes at once. So to set that up, let's actually plug this in here and plug this in here. Now by default, this is set to 0. So let's preview our wave texture real quick. And as I add this, basically I'm doing the same thing that I was doing before by separating this out in the z-axis. And if I just took away the noise texture, I was adding 1 to add the values into the vector. And it's really exactly the same thing. It's just with 1 node. We've got control over all 3. Now, because I want to distort this in more than one direction, I'm using this vector node, and I'm going to use a little bit of basic math. And this is a total hack, I guess, but if it works, it works. And it doesn't really matter how you, I guess, implement it or approach it, as long as you get a result that you like, I guess. So the way I do this is I'm going to grab the factor here, and I'm going to set this first one to subtract. And the reason for that will become clear in just a minute. Don't worry about it for now. I'll talk about that in just a second. And this one I'm going to set to multiply. So basically what I'm doing is I'm subtracting 0.5 the value and multiplying it by 0.5. Now if I add this into our second vector here, now the multiply becomes a control of how distorted the texture actually is. And it's going to be distorting in 3 directions because I'm using this texture as a vector to affect all 3 directions. Now the reason I subtract this, if I turn this off for a second and I turn the value up, you can see this texture is only being pushed downwards. And that's because our values coming out of the noise texture are only positive values. So remember when we said at the very start, our texture values, our mapping values go from 0 to 1 and from 0 to -1. Well, by adding a subtract in here, now these values that I'm getting are really going from -0.5 to 0.5, which means if I add this in, it'll actually distort in both directions, and it'll give you a slightly more usable setup to throw in here. And depending on how much detail you put in here, or how much you can distort this noise as well on top, and you can see you can immediately get really interesting and funky results. So while you might feel like you're limited to just the original textures that are in Blender, you can actually use this kind of technique to get even more out of them. And you could even distort the wave texture as well if you wanted to. And you can see we can get these really crazy, and some of them are more useful than others, but really crazy patterns for all kinds of advanced shading. So let me change this to one of my favorite setups. If we duplicate these, exact same idea. And we're going to have a look at the final output. And rather than putting a noise texture in here, I'm going to hit Shift S with the Node Wrangler enabled to switch this over to a wave texture. So now I'm going to use a wave texture to displace this texture. And for this one, rather than duplicating it, sorry, hit Shift S again, and we change this to a Musgrave texture. And this is just to show you the different options that you have. And I'm going to set this to diagonal, and I want to distort this quite a bit. And I'm just going to look at the texture itself, distort it. Here we go, maybe something like this. We can always come back to this. And if we just grab, we just disconnect this really quick, and we need to make sure that we're grabbing the original object vector here. So remember, we always need this first vector to get a basic sort of mapping on here, and then we're distorting it with the secondary one. And let's turn up the detail, turn down the dimension. Now we get this sort of interesting looking texture. But by adding the wave into this, now we get these really fine, almost organic looking lines. And if we start bringing some of our other techniques together now, what we could do is if we bring in a color ramp and we add in a few colors, now we can have almost like a mineral or a rock texture. And you can see how quickly you do some very, very intricate looking things without having to spend too much time on setting it up. So let's bring this white one over to green. And now it's just a case of tweaking where these colors are. And obviously there's so much detail in here, we won't actually be able to see every single color. So we might want to bring down the amount of detail in the wave, for example, or bring down the amount of distortion, bring up or down the detail scale. And the funnest part of this all is that it's just all very interactive. And if I bring down the lacunarity here, we're going to start seeing some of these colors, and we can bring them back in. And this is a very, I guess, psychedelic example, but it just goes to show you with some creative thinking, you can make some really, really complex and amazing patterns just by using this very simple setup. The idea is the same as the top once again, but we can just use different setups. So this is the one where we grabbed a noise texture and displaced or distorted a wave texture, and this Musgrave texture we distorted it by using a wave. And here you can actually see sort of the wave itself of the texture is still in there, and as we distort it more, it'll get crazier. And as we change the scale, you can see the larger size of the Musgrave texture, and I was wrong. So this is the Musgrave texture giving it the overall feel. And then as we change the scale of the waves, it just distorts it in many different ways. And again, if we bring this back into the color ramp, we get some really fun results. So to just top this off, if we want even more, if we want a better distribution of colors, we could throw in a map range here. And let's just preview this, because we can see there's a lot of black going on here, a lot of really hard contrast. And what we could do is bring in the minimum a little bit, so it's less contrasty, bring out the maximum a little bit, and just mess with these. And now when we color ramp it, we get a really nice, crazy, fun looking shader, or texture rather, that we could plug into a shader and do anything with that we wanted to. And you could use this for roughness maps, you can use this for color maps, you can really push this technique really, really far. But again, it's very simple to set up. You could even make your own node group out of this if you wanted to. But it's good to know that, like anything else, coordinates are just colors, are just numbers. And with a little bit of simple math in here, we can create some very interesting and cool results. So I hope this was somewhat enlightening, and you can get to work with this and have fun with this. I tend to throw stuff like this into, for example, when I'm using cycles. In this case, unfortunately, it won't work with Eevee, but when you're using cycles, you could use micro displacement and throw something like this in here, and all these details will become geometry, and you get really, really just cool and funky results. So it's up to you of what you want to do with it. You can push this any way you want, but yeah. I would say have some fun with it, and I'm definitely keen to see any results you might make or any combinations you might come up with. So with that said, let's move on to the next chapter of this. So it's time to bring some of these techniques we've talked about together into a slightly more practical example. And to showcase this, I want to create a dust particle system where each dust mote has its own sort of unique procedural texture. And to do this, what I'm going to do is I'm just going to create a cube, and this is going to be the volume for the dust, and set this up very quickly. So I'm going to grab an emitter, have it start at frame -1. lifetime, whatever. We just want this to be filled in the volume. So now we've got just a cube full of dust particles. And instead of setting the physics to Newtonian, I'm going to set them to none. So now they're just static. And that way I know they're in there and they're not going to move around. So I've got 1,000 dust particles in here. And let's say I want a unique texture for each one of these particles. Obviously, you don't want to be creating 1,000 planes with a simple texture, separate texture for each one. We just want to create one that is able to create its own separate sort of texture by itself. So to do that, let's start with a plane. And I'm just going to focus on this plane for a second. Let's grab our material view and start out very simply. So first of all, I want to make sure that my plane has a UV map. So I'm just going to project this from view. So I go into edit mode, go into top view, select everything and hit project from view. And now I know I just have a square UV map. Now by default, I believe Blender actually creates this, but it's just good to know that to make sure that we have the correct map. Now the first texture I'm going to use is the gradient texture. Let's grab this. Let's actually use UV coordinates for this because, well, it's just the easiest. We set this UV up and we want it to look correct. Let's go to the material preview and let's set this to be a spherical one. Now, by default, UVs actually start from the bottom here. So the middle of the sphere will be here. So if we set this to -0.5 and -0.5, we're actually going to slide the middle of the gradient over to the middle of our particle, which is great. Now we're going to throw in a color ramp because we want to be able to control sort of the edge. And we want to make sure that whatever kind of dust looking thing in here doesn't really reach the outer edge. And now we're going to bring together some of those techniques I was talking about earlier. So first of all, what I want to do is I want to create a noise texture. And we're going to use this noise texture to distort the gradient texture so it looks a little bit more like a dust mode. So I'm going to use object coordinates. Actually, no, let's use UV coordinates for this. These work just as well. And there we go. And we're going to set up the same thing we set up before. So we're going to grab our vector math, and that way we can add to our vector here. And we're going to do our little subtract and multiply trick. So let's bring in 2 math nodes. First of all, we're going to subtract. This is subtract. There we go. Oh, there we go. So now we've got values going from -0.5 to 0.5. And then here we're going to set this one to multiply, and this is just going to control the amount of warping that we're doing. And let's plug this into the vector. And now if we look at our dust mode, there we go. This is what we wanted. We just want this to be a little bit distorted. I'm going to bring the detail down a little bit, maybe bring the scale up a little bit. And that way we have just a little bit of a distorted dust mode. Push this up. There we go. And this could act as a dust mode. Now, I'm fully aware that when you're rendering something, dust is so small, you're probably not even going to see the difference. But the idea behind it is just a fun exercise, really. So you could do this to rocks. You could do this to pretty much anything you can think of. Because where the trick is now is actually, let me duplicate this a few times because we want to see our effect in action. If we bring in our object info node, and this same thing, the object info, we have a quick look at the particle info. It also has a random, and it's going to do exactly the same as the object info. So in case you're using this in a particle system, you could also use the particle info node. But as far as I know, the object info works just fine. And seeing that we've used that one before, we'll stick with this one. But yeah, you could use either one of these for the particle system, which is great. So let's grab this, and what we want to do is actually we want to offset this noise texture's vectors the same way we did them with the gradient texture, but we want to do it randomly. So that way, every single time this noise texture gets projected onto the gradient texture, because we're adding a random value to it, it's actually going to move it around. So what do I mean by that? It'll become clear in just a second. If we add another vector math in here and just plug in the random, you'll actually see you'll get random noise in here, because what it's doing is it's assigning values from 0 to 1 randomly. And this is adding that to the vector of the noise. Because this is a procedural texture, you're going to get sort of a different result every single time. Now, because this is going from 0 to 1, we want a little bit more randomness in here, because let's say we have 1,000 particles. What we can do is just add a math node in between here and multiply this by, let's say, 100, and that way it ensures that we'll get so much randomness in all these different objects we won't even be able to see the difference. Now let's go back to our particle system over here, and I'm just going to turn off the viewport display, and I'm going to turn on the render. I'm going to set it to object, and I'm just going to use the very first plane. And if we go in and look, you can actually see each single plane in here has a different texture. And we're only using that first one, remember. If we just hide these for a second, we're only grabbing the first one, and because it's based on that randomness and it's using that noise, now each of these has a random texture. Now, just to finalize this and to make it look right, what we're going to need to do is in our options, I'm going to just grab, let's say, a diffuse texture, or a diffuse shader rather, go, and a transparent shader. And I don't want to see the edges of this, so let's mix these together. We're going to use this color ramp, throw the transparent in the first one, and then mix in the diffuse. And now you'll see this is still an issue because we still need to set up our transparency for Eevee. And the way we do that is just to set our blend mode to alpha blend. And there we go. Now we have all these different dust modes. And if we go back into our cube, we could change the scale maybe to 0.01, some randomness in there. And if we set the rotation, randomize, now we've got all these random little dust motes in the air. And really, we only had to create 2 objects. The only reason I created these other planes was just to illustrate the point. But there you can see, now we've got all these random dust motes. And if we zoom into each single one, they'll have a different texture every single time. And again, this maybe is a bit of a stupid example because from here you won't really see the different dust modes. But it's good to know you can do this with any type of texture, whether it's just an image texture or procedural texture. So yeah, I hope this was somewhat enlightening. I use this all the time. I've got a file with a particle setup like this that I just copy and paste from. But here you can see by just manipulating the vectors twice, first to offset the noise and then to use that offsetted noise for each object to manipulate the gradient, we get really cool little dust modes, and we can use this for, like I said, anything you want really. So yeah, I hope you enjoyed this video, and let's move on to the next one. In this example, let's talk about a very quick sort of interesting node that you have in Eevee that you don't have in Cycles. And that's the shader to RGB node. I'm just going to set up a very quick scene here to see what's going on. And really, I just want Suzanne and a couple of lights and a floor just to be able to explain the concept of the shader to RGB node. And it's actually incredibly powerful if you want to do sort of more interesting looks and non-photorealistic looks. And I'm not going to go into an entire NPR workflow, but I do want to show you some tricks with this and just in general see how we can have some fun with it. So to set this up, I'm just going to add a few more lights. So we have a bit of lighting in the scene because this is going to be important. Actually, I wanted to set that to 50 rather. There we go. And let's grab one. Let's duplicate it. Maybe put one sort of around here. So we've got some lighting and some lighter and darker parts in the scene. Let's do one more in the back here and point it towards Suzanne. There we go. So now we've got some rim lighting as well. And maybe let's put this a little bit closer. There we go. And as we look at her, we've got 3 light sources, one from the top, one sort of from the front, and one from the back. And it doesn't really matter if this is a pristine work of art. It's really just to explain the concept. So to do that, I'm just going to add a principled shader node and look at Suzanne in the viewport here. And the shader to RGB node it kind of does exactly what it says on the tin, but it's good to understand what's actually going on. So if I just plug this in, you'll see if I then preview this with a viewer, and let's preview the color rather, you can see nothing seems to change. But what has happened in the background is we've actually got a shader output and we've converted this to a color output. So this viewer, all it really is just an emission shader. Let me delete this and just show you with an emission shader. So we basically turn this shader into a color. So what we get a lot of control back basically, and we can do more stuff with this if we wanted to. So if we plug this into a color ramp, now it's just going to grab those same colors from our shader. But let's say I want to plug in 2 more colors here, and I'm going to set these to constant. Now what I can do is start creating some sort of like halftone shader. And because this is a shader to RGB node, if I move any of the lights around, you'll see the shader will actually still react to the lighting. So we get a very interactive and interesting looking effect that we can definitely do some cool stuff with. Now, because we just grabbed some white lights and a white shader, this shader to RGB node is all just going to be black and white. Let's actually change this top one to a red light, just as a proof of concept. I'm going to turn it up slightly. And what you'll see now is that even though down here my regular plane, which is just white, and a normal material is going to start turning red, this one isn't. So the reason for that is because of this color ramp. The moment we turn off the color ramp, we get a normal sort of looking thing, but this is just a color map that we're piping into an emission shader rather than the actual shader, even though visually they're pretty much no different. Or just very little, or there's very little difference at least. But again, if we add the color ramp into this, even though the shader is white and the light is red, or we could even make the shader red, it's going to affect the overall tone and the contrast. But because we re-ramped this, now we're not actually getting that color itself. So generally, if I'm doing sort of odd NPR stuff, I'll use white shaders and then mess around with the color ramp here as well. Now we could even set this to linear if you wanted a slightly softer fall off, and then you could increase sort of the contrast. You can see as we bring these a little bit closer together, still get that effect a little bit, but it's not quite as hard of an edge. Now, your material properties will also affect the shader to RGB node. So again, if you mess with the roughness and the metallic and things like that and the specular, it will affect it, because effectively all you're doing is just grabbing the output of this shader and putting it into a color ramp by way of a shader to RGB node. Now things get even more interesting when we start really pushing this effect and see what we can do with different sort of 2D color effects, because now we can start mixing this with other stuff. So first of all, what I want to do is I want to create like an odd color scheme for this. So let's do maybe orange and blue or something like that. There we go, just to get a sort of a weird effect. And if you want this to look a bit more correct, you can bring the orange down a little bit darker and maybe the blue down ever so slightly. So now you still get sort of a normal going from dark to light look. It's just like a 4-tone effect, I guess you could call it. Now, let's get crazy with this, and let's put in, not a mix shader, actually a mix color, or mix RGB. There we go. And let's just duplicate this color ramp and put that in here as well. And I'm just going to set the factor to 1, so we're just looking at the second color ramp, and I just want to set up a wholly different set of colors in here. So let's go for something a bit more psychedelic. There we go. And it's really just to illustrate the main differences. And what we could do is now we could even go in with something like a layer weight. And we've got the Fresnel here, which we could use to maybe mix these two together. So we'll have to do a little bit of color ramping on the Fresnel just to get it to look right. So just by increasing the contrast, let's see if we can bring this in. Now you can see we've got that similar sort of look in 2 colors, but depending on the angle, we're getting slightly different looks. So if you want to do something very comic book style, or you know, you need something that's very non-photorealistic, you can definitely get away with mixing a lot of these shaders together. Now let's do one more thing, and let me bring in brown on this one a little bit. Maybe let's have a look at some of our lighting here. So let's move this, actually instead of turning it, let's move this over. Now you can still see it still reacts to the lighting, so you can do some very interesting stuff. And what you could even do if you wanted to is, rather than using an emission shader, let me just disconnect this for a second, you could pipe this back into a principled shader. And now we've got shaders affecting shaders, so you still get that sort of effect of all the color ramping and the colors, but you get a normal sort of principled shader with roughness and specular and that kind of thing. So as you can see, you could push this effect super far. Now I just wanted to show you this before I move on, because we're going to keep using the emission. And let's say I want to create sort of like an almost an edge here in an even different color. Again, what we could do is we could add in another, where are we? Another layer weight shader. And this is a very hacky and quick way to do it, but it's really just to show you what you can do. And I keep adding mix shaders in out of out of habit, but I need to add in a mix RGB. Let's grab a Fresnel here. Let's just have a look at another color ramp. So again, just previewing this. So I want to keep the edges, but take away the inside. So with that done, you can see this is set to white. Now we could even add in like a colored edge if we wanted to. You can see we get a very psychedelic sort of look, but that's okay. This is just a case of showing you what you can do with this and how to really control it. So the more contrast we give this edge, the weirder it will start looking. But you can see we've got all those different components of all those different shaders, and they're still editable. And as we move our lights around, they're still going to react to all the lighting. So let's say we move this back, you can see the darker parts still react. And there's so much fun to be had with this. Again, I just wanted to add this into the shading section to show you the power of this. And this is something that you only have in Eevee, which I thought, which kind of made it the reason I thought it would be important to mention. But yeah, as you can see, we've created like a completely nuts shader. If I just turn off this first one, now we still get that 4-tone effect, and we get sort of like a yellow edge that we can control by just messing with the blend as well here. And all of these Fresnel effects are going to work well on curved surfaces. They won't be quite as visible on flat surfaces, but it just goes to show you that you can do a lot with some creative thinking. And this shader to RGB node is seriously one of the cooler things Eevee has to offer, just because, again, we could make this more metallic, and you can see it immediately starts feeling more metallic. And now a lot of the colors disappear because we've turned down the roughness. As we bring it up, you can see that color palette comes up completely. And if we were to set this to linear, then you'll see the fall off will be a little bit less harsh, and you can actually see that roughness at play even more. So if you want to create a completely over the top crazy shader, you can, and it's good to know that you've got the option there. So now we've got a bit more of that hard edge from the second one. And let's bring up the roughness again here. Now you can see you've got a mix of hard and soft edges, and depending on the Fresnel angle, you get different colors. And yeah, again, this isn't really the most beautiful thing I've ever created, but it was just to show you that you can get really far with this. So I'm going to set this back to constant, just to give that bit more of a comic book look. Let's bring down the metallic and kind of leave the roughness sort of in the middle. That's fine. Oh, typed the wrong thing there. There we go. And yeah, so I hope you definitely give this a chance and explore this, because like I said, there's a lot of fun to be had. You can use this as a mask as well if we go in and, you know, if we, our first little shader to RGB move here, if we just pipe this in and you increase the contrast between the two, you could actually use this as like a black and white mask for maybe a texture or something that you can blend in there as well. So the possibilities really are endless, but I just wanted to show you again that it's in there and that you can mess around with it. All right, and with that said, it's time to move on to the next section. So for this video, I want to talk a little bit about transparency in Eevee, and it's good to know how to set things up properly and what your different options are. So to do that, I've just set up a very simple scene, which I want to walk you through before I start talking about it. So we've just got a ground plane with nothing on it and 3 lights above each one of these objects. And these objects have fairly similar shaders. So as you can see in this one, really I just have a gradient texture, which is a sphere, and I've just color ramped it a little bit and offset it in the UV so it's in the middle here. That's just important to note. And the same, this this material rather, is exactly the same. Nothing special there. And this last one is sort of another way you would set up transparency, and it's just really the same sphere, but I'm mixing a transparent shader with a diffuse shader. And you can see these two already are like these two materials, even though they're pretty much the same. They're quite similar, but this one already gives us a different result. But in no 3 of the cases are we getting transparency. So let's actually set that up. On the first one here, I actually have this plugged into the alpha slot. And as you can see, even though this has roughness, and let's actually turn off the specular here. you can see as I plug this same map into the alpha, nothing really seems to happen. And the reason for that is in Eevee, we need to think about transparency because there's a couple of different options, and let's run through each one. So for this one example, what we could do is we could set the alpha to alpha clip, and basically you can kind of choose the threshold of the clip, and you can see if we set this to 0, then sort of anything that's black will be clipped and any value that's even slightly above black will show. So if you want a hard edge, or you have a very sort of simple black and white hard edged map that you want to use, alpha clip might probably be the best one to use, but it's up to you. But again, because we have sort of a softer fall off, and you can see as I increase the fall off a little bit here, we're not quite getting what we want. And when we talk about transparency, we need to talk about the shadows as well, because we have a light above here and we're kind of seeing that this shadow doesn't really make sense. So we've got sort of the same options in here, and we could either set the shadow to none, which is if we just want a very simple 2D effect. But if we set the alpha to alpha clip, then, or sorry, the shadow mode to alpha clip, there we go, then we're going to get sort of the same idea where the shadow is being clipped sort of the same way. So generally, unless you need it for a specific reason, try to keep these two modes somewhat similar to get more predictable results. Now, in this case, for the second one, and I've plugged it into the alpha as well, what we're going to do is we're going to use the alpha hashed method. And you can see now, if I set this both to alpha hashed for blend and shadow mode, we're going to get those really nice soft fall-offs, and even the shadows in between are going to have soft fall-offs. But the problem with this is that while it is really accurate, it needs a lot of samples to get it to look good. So if we set the viewport samples even up to 64, you can still getting a lot of noise. Let's set it up even higher. And even at 128, we've got a lot of noise. Now, alpha hashed might be the one you want to use in case of a layered object like this, just because it provides you with the most detail. But as you can see, there's a lot going on and it has a really hard time calculating it. So in most cases I've found, and let's go to this third object, and I've just set up the transparency different here, just as a proof of concept so you can see how it affects it sort of in different ways, even though these shaders are pretty much identical. So if we now actually set this final one to alpha blend, you can see now we get a nice sort of soft fall off, but we're not having to deal with those shadows, or sorry, with that noise rather. We can set the shadows here as well to alpha hashed, and for shadows that's sort of what we're left with. Unfortunately there's no blend shadows yet, but it's good to know that for cases like this you're going to get the best result with the alpha blend and the alpha hashed setup here as well. So it doesn't really give us a lot of extra explanation, but it's good to know the differences between these three. So if you've got a hard edge, maybe alpha clip is best because it calculates out quite fast. If you've got an edge which is very soft with a lot of detail, and you can see as we pull this up, this gets really nice and soft and it works out. And with the blend, if you just got sort of for most use cases, this will work quite well. As you can see, the blend gives us a really nice sort of look here. And if you want, you could even turn off back facing if you only want to see the front of it as well. But that's not super necessary. But I did want to run through these transparency options in Eevee because you do need to set them up and specify them in each shader. And each one of them has its advantage and disadvantage. So yeah, we'll use this in some other stuff as well, but especially if you're doing 2D stuff like UIs or lower thirds or anything, you know, with text or an image that you want to use. It's good to know that alpha is available in Eevee, but you do need to kind of set it up and make it work for you and make sure you know what you're doing when you're choosing all the different modes down here. So yeah, hopefully that was a bit illuminating on how to set up correct alphas in Eevee. And yeah, with that said, it's time to move on to the next section.